Hello, everyone. Welcome back to AIQuantEasy, from zero to hero. Recall in the last episode, we introduced the concept of different types of stock indicators that can be directly computed from daily stock prices and volumes. In this episode, we will show you how we can derive those stock indicators by using Python. This is where we load 5-year daily price and volume data of SPY Spider from Yahoo Finance. And also, we remove those unnecessary columns. Let's run this cell. Then we get this data frame, right? So we have this open, high, low, close, volume columns. So now I will show you how to enrich this stock data by adding extra columns for those indicators. Now we will look at how to derive indicators based on their definitions. After that, we'll talk about how we derive indicators by directly using the existing Python packages. So first, directly based on definitions. All the indicators that we discussed in the previous episode can be derived directly based on their definitions, because all those indicators actually are based on price information and volume information. The first one that we will look at is simple moving average. Assume that we want to use simple moving averages to reflect midterm and long-term trends of the stock price movement. More specifically, we want to derive 100 simple moving average, 200 simple moving average, and 300 simple moving averages. We can easily apply a function called rolling on the close price columns to derive the simple moving averages. Just by using this 100 simple moving average as an example. So what the rolling function will do, basically for each close price, the rolling function will first create a subseries that includes the most recent 100 close prices, including the current one, then calculate the mean over this subseries, over this 100 window, and then directly apply this mean over this 100 most recent closing prices to the current close price. Then the rolling function will shift to the next closing price and do the same thing. Okay, so in this way, actually we can easily append simple moving averages to the data frame. So let's just run this cell and show what we have. So you can see that now we have 3 extra columns: 100 simple moving average, 200 simple moving average, and 300 simple moving averages. You may notice there's some null values in the first several rows. So that is because for 100 simple moving average, for the first 99 days, we cannot form a subseries that include the most recent 100 closing prices. So that's why we don't have the simple moving average for 100 day can be calculated. That's why we have null value here. The same for 200 simple moving average and 300 moving averages. Now let's look at the exponential moving averages. Assume that we want to use exponential moving averages to reflect the short-term price trend. More specifically, we would like to calculate 9-day exponential moving average, 12-day exponential moving average, and the 26-day exponential moving averages. Let's just use this 9-day exponential moving average as an example. We can simply apply EWM method by specifying the span parameter to be 9 and apply this function to the close price column. So what does the EWM will do? It will form, again, for each close price, it will form a subseries of weighted close price that covers the 9 most recent days, including the current day. So how we calculate weighted close price for each day within this 9-day window? So basically, this is a formula for us to calculate the weighted close price. Okay, This is a recursive definition, as you can see that. So this definition indicates that more recent higher weight will be given to the close price. When we move towards the early part of the subseries, the weight of the closing price actually is decreasing exponentially because of this recursive definition. Then over this 9-day window, we calculate the mean of all this weighted closing price. So the same thing that we calculate the 12-day exponential moving average and the 26-day exponential moving averages. In this way, we append 3 extra columns for the exponential moving averages. Let's run this cell to see what we get. So you can see that here we have 3 extra columns for EMA 9, EMA 12, and EMA 26. Now let's talk about MACD or MACD. By definition, MACD line is obtained by subtracting EMA 26 from EMA 12, right? So we can easily add this MACD line column by doing this SPY EMA 12 minus SPY EMA 26. That's it. So let's run this cell to see what we get. So we get this MACD line column. By using the similar way, we can derive all the indicators that we discussed in the previous episode based on their definitions. But now, I want to show you how we can derive different stock indicators by using an existing Python package that is called TA. So TA represents technical analysis. So the first example I want to show you is Bollinger Bands. As you recall, Bollinger Band is a volatility indicator. So first, we import Bollinger Band from TA.volatility. Then we create a Bollinger Band instance by calling this constructor, right? When we call this constructor, we specify that the Bollinger Band is constructed based on the close price. And the midline is 20-day moving average. And then we have this higher band, which is 2 standard deviation above the midline. We also have this lower band, which is 2 standard deviation below the middle band. Once we have this instance created, we can easily call a couple functions via this instance to get our band. So the first one, we call this Bollinger underscore M average to get the middle line, which is a 20-day moving average. Then we call this Bollinger underscore H band via this BB Bollinger Bands instance to get the higher band. Then we call Bollinger underscore L band via BB to get the lower band. Okay, let's run this cell to see what columns we derive. So here you see we derive these 3 columns. Middle line of the Bollinger Band, which is 20-day moving average. Higher band, 2 standard deviation above the 20-day moving average. And the lower band, 2 standard deviation below the 20-day moving average. Now let's take a look at how we derive RSI, another indicator, relative strength indicator from TA. First, we import RSI indicator from TA.momentum. Recall that RSI is a momentum indicator, right? Just as how we derive a Bollinger Band, we first use a constructor of this indicator to create the instance of this indicator. So here we use this constructor RSI indicator to create an instance called RSI underscore 21. When we call this constructor, we specify that this indicator is calculated based on the close price, and it's based on the 21 most recent days of the price movement. So once we have this instance constructed, then we call this RSI method to get the RSI values. So let's see what do we get by doing this. So we got this new column called RSI 21. So let's continue. We're trying to derive OBV from TA package. So OBV, unbalanced volume indicator, is a volume indicator, right? So we import unbalanced volume indicator from TA.volume. Again, we call the constructor to create instance of OBV. So when we call this constructor, we specify the close column and the volume column, because OBV is calculated based on both close price and the trading volume. Once we have this instance constructed, then we call this unbalanced volume method over this instance. Then we can get the OBV value for each day. So let's just run this cell to say what do we get. Yeah, we got this OBV column. You see, using the similar ways, we can derive all other indicators that we discussed before from this TA package. You can practice to derive different indicators.